everyone. Well, I've been asked by one of our users, Mark, if I could make a video to show specifically how to use a user DXF as a counter-rotating vane system to check out the visuals. So let's start by loading Mark's DXF, which I believe is called plywood something. My system takes a while to open the mask. I have a lot of files. Alright, so plywood wheel 24 by 24. So one of the first things that you need to worry about when you import a DXF is how many constituents are there to it, because oftentimes when I show examples there is only one piece to it, so this is something you don't often see. If we look up at our layers menu, which is important, we should stay on the layer that we're going to be working with. So I'm going to select this unnamed layer. In fact, since the main layer is empty, I'll just delete it. And now we have just the unnamed layer, which is 4 chains. So when something is 4 chains, it probably makes a great deal of sense to select them all by the drag box will select anything inside of it. Right click and select group. We now have one object, so if we select any object within the object, it selects it all. Basically one object. Now in order to make a counter-rotating vane system, we want to have 2 of these objects. One of the easiest ways to do that is to select the object and hit mirror, and I will create a symmetrical chain, one in opposite to the first one, because they tend to give the best visuals. It's not necessary, of course. You could have 2 that are identical. They'll just give a different visual. Alright, so now we have 2 objects because the mirrored object is also automatically grouped, and as you can see, selecting any part within it will select the entire object. So next, let's go into kinematics mode and take a look at the properties of these objects. If we're going to do a kinetic vane system, it's probably best to turn off their gravity. Having gravity doesn't really do much good for us on a kinetic vane when we're just checking visuals. It can have some use when we're triggering and such, but temporarily, let's turn off the checkbox, responds to gravity, and hit update all so it updates both groups. So now, if I hit run on this, you can see that the vanes are hitting each other and turning red, and it's not very pleasing, really. So let's stop these, select the properties on both of them again. And one way, and there are several, to stop 2 objects from colliding with each other is to set them to a group other than 0 and identical. So let's set them both to group 1. This means that they will no longer collide. I could also have unchecked allows collisions. That's another method. And there's a third method up here on the bar called set collision categories. That's an advanced topic, and I'll do a special video on that. Basically, these 3 collision category groups, or 3 ways of controlling your collisions, allow you to build very complex machines with complex collision orders. But for the moment, we won't worry about that. I'll just mention that you can either uncheck allows collisions, or you can set them both to the same group number other than 0. In this case, I'll set them both to group 1. I'll hit the stop button to reset them. Always hit stop to make sure all your changes are taken. And now if I hit the run button, you'll see nothing moves. Time is going by. I can grab an object and move it individually, and it doesn't affect the other one. This is all as you would expect. So I could now put one vane on top of the other if I wish and drag it around in order to get a kinetic effect. But there are at least a couple of other ways to do it. So let's take a look at one way. Let's put a motor on the screen. Now, when you put a motor on the screen, you have a choice between putting a motor on one object, which basically puts that motor on the plywood background and attaches the shaft to the object so it always turns in the direction the motor indicates, in which case we'd have to put 2 motors. But you can also put one motor between 2 objects by selecting 2 objects at once and hitting motor. You'll hear the sound of the motor being applied, and after that, if you hit the red button for reset, you'll see each motor now has half a motor symbol. This means the motor is going to turn the 2 vanes at once. So let's hit play on that, and you can see one motor is going one direction and the other vane is going the opposite direction. This is, of course, Newton's third law. If I apply a force to any object, there is a equal and opposite force applied to the other object. So as the motor, which is on one of these vanes, rotates, it does push the opposite vane in one direction, but the motor itself gets pushed in the opposite direction. So here we have two vanes counter-rotating. Now you do have to leave kinetics mode, select one object twice in order to make it movable, and then you can move it on top of the other vane. Okay, so now we have the two vanes rotating by motor. Now I've given this motor a power of, I believe, 40. Let's stop this. And if I select both vanes and I press for motor, we'll get the properties of the motor. And I've set this one to a force of 10 with an RPM of 5. Let's up that RPM maybe a bit to 7. Hit stop to make sure everything's taken and hit run. And our vanes begin to move. Now, that's much as you would expect for vanes that are slowing down at the moment. If I grab one and pull it, you can see it impacts both vanes. And that's to be expected, of course, because as you pull one, you'll still get that equal kickback on the other side from the motor. So it begins to affect both of them. And this begins to give you the kind of representation you want. You may have to change the motor's RPM to get a more realistic display for whatever you're designing. I'd like to make a couple points, though. I'm going to take us out of kinematics mode. You'll see in the background here I have a grid, and that grid is always representative of whatever I have set under display set default extents. So when you load a mech or a project from someone else, you may find it looks absolutely huge compared to your table, or it could look small compared to your table. Mechs will convert from metric to English. So the person who saves it in metric, you can still load their mech even though you're in inches, and it will shift it to inches. However, they can be fairly large because some of us, when we're playing, we don't take much note of how large something is. But if I move my mouse, you can see this one is approximately 24 inches by 24 inches. My table, however, is only 16, so it looks large compared to my table, but everybody's tables can be a little bit different of a size. So you might want to check and see what you're under display, what your set default extents is set to, because that just simply represents what your grid is, and is meant to be your table size. Okay, I'd like to mention one other thing, I think, and that's how to get a somewhat even more realistic display, and that's by using magnets. So I'm going to select both of these items and turn off the motor by selecting motor and delete. And as you can see, the motor's gone. So at this point, if I hit stop and run, the vanes don't move at all. I can grab them and make them move individually, but they have no movement source on their own. So I'll stop this. And now I want to separate these two vanes so that I can illustrate a point here. So I'm going to turn off kinetics because you can't move an item until you are out of kinetics. Okay, here's our two vanes again. And on one vane, I'm going to apply a magnet. And when I hit stop, you can see a magnet has appeared. It's this red thing. Red indicates, I believe, a south pole. If you right-click on a magnet, you'll find in the menu Adjust Magnet Properties. And here I have a magnetic strength of 5. I'm just going to give that, or 1. I'm going to give it 5 newtons, and it's a south pole magnet. It has a diameter of 0.8 inches. The diameter makes a difference on magnets because every magnet is a unipole sphere. They don't exist in nature, but for a metaphor for placing on a simulation, they work fairly well. They do allow for perpetual motion machines and so on, however, because they are unipolar. So I'm going to set this one to a magnet strength of 5, and it has a south pole. And on my other vane, we'll select that, and I'll add a magnet to that as well. And hit stop, and there's our magnet there. I'm going to move that also out to the side. Now when you move something, you can see here I'm moving a circle. That probably means I'm moving the center. And I was, so I'm just going to move that center back and move the magnet instead. Now on this magnet, let's adjust the magnet properties and set it to a north pole. And it turns green. So a north and a south pole will attract each other. Now you cannot just select a vane and push magnet, because if you did, a second magnet would appear. And in fact, we'll use that. What the heck? Let's move this over here and leave it north. Now let's give this magnet a strength of, say, 3. And this magnet over here, we take a look at its strength. We'll give it a strength of 3 as well. These are newtons, and it's a guess until such time as you've tested it. Okay, and we'll leave that one with a 5.
You can put as many magnets on an object as you wish, and this is why clicking on magnet will not bring up their properties. There's no way to tell whether you want to add a magnet or look at one's properties. So magnet properties are always dealt with a right click and adjust magnet props. And I just moved that magnet, so let's move back here. Alright, so I'm going to leave kinematics, select that vane, and move it back on top of the first vane. Now when I do that, its magnets may not move properly, but the second you enter back into kinematics mode, it will adjust the database and everything will be fixed up. So now let's see what happens when we hit run and we have magnets. You can see that these two magnets over here are attracting each other, the red and the green, and they're on different vanes, so they make it go back and forth. I'm going to slow my simulation way down here so that I can grab one of these, and I'll give it a pull to pull these apart. The dynamics of these are such that they will probably repel and attract each other for quite a while, change in directions at seemingly random, and that makes it look very much like what you'd expect from something like Monarch as a device. Now again, don't be shy about adjusting your simulation speed. It's very important in all of these, I find, to adjust it, especially when you have things at the extremes of a radius of movement. This allows the time between updates to be fast enough that it can see the interactions between magnets. So especially when you're using magnets, expect to have to lower your simulation speed to lower the granularity of time so that things begin to be more accurate. And at this point, when you have a simulation like this on the screen, zoom it as large as you can, sit back in your chair and look at it, and you'll find it's a very good representation of the graphic that you would expect. I will be adding video at some point in order to do a more detailed production video of it to give you an even more realistic visualization, but until such time this works fairly well. As you can see, when two magnets that are the same come together, they reverse the direction of the vanes and push it apart, and when two different poles approach each other, they'll actually give a momentary kick and then a slowdown as they leave. So magnets are a really good way to get a visualization of your vanes. You may find that some settings, such as motor power, do not convert well between imperial and metric, so sometimes when you load a mech you may have to adjust someone else's motor values. Magnets I've worked on recently, and they're pretty good across the two domains, but I'm still looking at regulating power on some objects. Anyway, that's it. That's a quick look at how you could make your own vanes display themselves visually to get an idea of what your kinetic sculpture would look like. Between dragging them around, magnets, motors, and your simulation speed, you can come up with a pretty good realistic simulation. Have fun.